Okay guys, welcome back. Session 4 now. We finished with the Pascal's triangle, although we might see it in one of the questions we look at today. And you might think, how am I going to link this to Surds? See soon enough. And we're looking at Surds today. Now some of you will have seen a bit of Surds already, so for some of these questions it's a bit of a recap. It's nothing new, but you'll find some of the questions maybe a little bit more challenging. Certainly this is going to help you with the GCSE, sure. Okay. So do follow the examples, try and have a go yourself. Remember, pause the video at suitable points and do have a genuine go at answering the examples before you see me answer them. And then there's a few questions to answer at the end of this session. Okay, so just be prepared for that as well. Okay, well done guys. Okay, let's get straight in. So I'm going to go straight in with a few examples. Okay, and we're going to look at simplifying first, Surds. So let's simplify the following. Question 1, root 32 minus root 18. This would almost certainly appear in the non-calculator paper. Okay, right, so what you need to do is you need to separate these into the biggest square number. It's good advice to just put a list of the square numbers down the side, which is going to help us. I'm not going to go any further than that. If I needed to, I can. But 32, the biggest square number that goes into that is 16. So it's going to be root 16, root 2, because the two numbers need to times 32. And 18, we're going to have a root 9, 2 there. Okay. Now I can simplify this a bit easier because root 16 is 4 root 2, and then root 3. No, root 9 is 3, sorry. So 3 root 2, and then I can just, like algebra, 4 root 2 minus 3 root 2 just becomes 1 root 2 or just root 2. So root 32 minus root 18 just goes to root 2, and you can check that with your calculator. Quite nice. Okay, question number 1. Bit of a recap. Question 2. Let's see, now you've got to, so if we're multiplying surds, if you multiply surds, you just multiply the numbers, okay? Nice simple rule there. So root 6 times root 3 is going to be root 18. And then we know from the previous example, root 18 can be split into root 9 root 2, which is 3, 2. Okay, it's always good to have the surd smaller. Okay, the smaller the surd, the better. Computers can calculate smaller surds quicker than they can big ones. Okay, that's the rationale. 3, we're going to do a bit of expanding now. Expand and simplify. Again, pause the video if you need to. Okay, so expand and simplify that. You just need to go through it methodically. So 4 times 4, 16. 4 times that is going to be minus 8 root 3. Root 3 times 4 is plus 4 root 3. And this is probably the hardest one. Root 3 times negative 2 root 3. Well, it's going to be negative 2 root 3 squared. Now, root 3 squared is just 3. So let's tidy this up a little bit. It's going to be 16. I can group those two together. Minus 4 root 3. This is going to be 3 times negative 2, which is going to be minus 6. Answer there, 22 4 root 3, which is quite nice. I can always check this on my calculator. Okay, so you can type it in. Again, this is the calculator I'd recommend, the Class Whiz. 4 plus 3, 4 2 root 3, and hopefully so is, oh, I've made a mistake somewhere there. Yep, I made a mistake. So it's always good to check your answer. There's a mistake here, isn't there? That should be 10, not 22, because it's 16 minus 6. Okay, this will appear in the non-calculator paper most certainly. So just be aware, try and avoid the silly mistake I've just done. Right, a couple more to go. Right, let's expand the following. So expand 2 plus root 3 to the power of 4. Okay, Now, you could do it longhand, or you make use of Pascal's triangle here. And I'm going to make use of Pascal's triangle. So because it's a big power, that's the whole point of Pascal's triangle. So I'm just going to recalculate Pascal's triangle here. And I remember the first row is to the power of 0, that's to the power of 1, to the power of 2, to the power of 3. That is what I want, to the power of 4. Okay. So A is equal to 2, B is equal to root 3, and hopefully you're becoming a bit more expert at this. So the first term, 1 from Pascal's triangle, A to the power of 4, 2 to the power of 4. The second term, 4 from Pascal's triangle, A to the power of 3, 2, 3, and then B. Third term, 6 from Pascal's triangle, 2 squared, root 3 squared. Fourth term, 4 from Pascal's triangle, 2 power of 1, root 3 cubed, and the final term, 1 from Pascal's triangle, and then it's root 3 to the power of 4. Okay, so hopefully that's a little bit of a recap of using binomial expansion and Pascal's triangle again. But we do need to simplify this a little bit. So the first term, 2 to the power of 4, well, that's going to be 16. Second term, we've got 8 times 4 there, 32 root 3. Third term, we've got root 3 squared, which is 3. 3 times this, so we've got 18 times 4. 18 times 4, I'm going to be very lazy. 72. Got 72 there. Next term, we've got root 3 cubed. Now, root 3 squared is 3, so that's going to be, that in itself is just 3 root 3. Okay, have a little bit of a, maybe pause just to think why that would be true. We've ended up with 4 times 2, which is 8. 8 times 3, 24 root 3. And the final term, now 3 to the power of 4, well, that's going to be 3 to the power, root 3 squared is 3, so it's actually going to be 3 times 3. So it's going to be plus 9, that. Now, if I group all of these together, 16 is 86, add 9 is 95, plus 26 root 3, okay? Tough example, but just pause that and just make sure you're really understanding what's going on there, and we'll do a quick check on our calculator. Hopefully I haven't made any silly mistakes with this one. It doesn't even give you, so let's just see if that's the same. If I minus 95 plus 26 root 3, if it is 0, I know that I'm correct. If it's not, oh, that means I've probably made a mistake. Let's go and have a quick look, see where I've potentially made the mistake. But definitely 2 to the power of 4 is 16, I think that one's right. This one's 8 times 4, which is, yeah, that one's right. This one, let's just check that one. 6 times 4, 3. Yeah, that one's right. Next one, let's just try this one. So it's going to be 4 times 3, yeah, I think that one's right. And the last one, root 3, definitely 3 times 3, which is 9. I can see where I've made the mistake. I haven't done, I need to add those two together then, and that's 56 root 3. Not, yeah, so there's the mistake again, making a few silly mistakes here, but that's why using the calculator to find those errors is really, really useful. Okay. Right. That is a bit of a recap on the basics of surds, I suppose. We're now going to look at rationalising. Okay, rationalising. This means get the surd off the bottom of a fraction. So if it was rationalise, okay, 2 over root 7. So that means get the root off the bottom of the fraction, and in order to do that, we times the top and bottom by the surd. It's got to be, you're not changing the fraction because you're still timesing it by 1, so that doesn't change the fraction. But that does mean on the top we've now got 2 root 7 and on the bottom we've got 7. Okay, so that's what rationalising means. Again, there's a little bit of some advantages of this if you're using computing. So that's again the rationale behind it. So if you've got a slightly different case, so this is where you've got 2 terms on the bottom. We want to rationalise this. And again, you might want to pause the video, have a think about what you might have to times the bottom by and the top in order to not have a surd on the bottom at all. Okay. But what you would need to do is multiply by exactly the same, but you switch the sign on the second term. So switch sign on the second term. And in order to do that, you'll find that it does eliminate the surd on the bottom. Okay, let's just work that through. So the top though, let's work from the top first. That's going to be 12 root 2 plus 3, and remember you can times those together, 3 root 10. Okay, and then on the bottom we're going to end up with 4 times 4 is 16. 4 times plus, you can probably see that they're going to cancel out. Then we've got minus 4 root 5, and finally we've got minus root 5 times positive root 5, which is minus 5. Okay, now if I just group those together, on the bottom, we end up with, those 2 cancel, we end up with 11 on the bottom. And that, I don't think, you looked, can you simplify it further? I don't think you can. That would be our answer. Again, let's do a quick check and hope I haven't made yet another silly mistake. Or minus root 5. The calculator will rationalise it for you. Again, it would appear in the non-calculator, but yes, I have got it right, slightly different order, but that's absolutely fine. And there we go. Okay. Right, that concludes today's session on surds. I now want you to do a few questions, please. These are all from the textbook this time, so it's page 20, exercise 1G. Questions 1 to 6, I just want you to do the first and last part. Okay, so the first part of the question and then the last part. There's lots of intermediary questions, but just the first and the last is sensible. And then I want you to do questions 8, 9 and 10. All of that, all parts. Okay. And then after that, I then want you to go to exercise 1H over the page and do evens only. So that's questions 2, 4, 6 and 8. It's a few questions this week, but it's a really important topic to get your head around. So spend some time working through it. And obviously speak to me if you've got any questions. Okay, well done guys.